7.5. Using context managers. We're going to see how to customize the behavior of with blocks by writing our own customized context managers. We're going to see how to create context managers in two ways. First, by using the context lib module's context manager decorator, and second, by setting up class instances with the proper protocol methods. Context managers are pieces of code that plug into Python's with statement. A with statement contains a block of code, and the context manager is able to run its own code both before and after that block is executed. And the code that runs after the block is guaranteed to run no matter what happens within the block. The Python standard library makes quite a lot of use of context managers. Open files can be used as context managers, which guarantees that the file will be closed at the end of the block. Lock objects can be used as context managers, in which case they acquire the lock before the block and release it after the block is finished. SQLite database connections can be used as context managers, allowing them to automatically commit or roll back their transactions when the block finishes, and so on. There are other examples, but we can already see how useful context managers can be. They simplify the code by combining setup and cleanup into one thing, and they improve the code by guaranteeing that the cleanup code actually gets run. So how can we write our own context managers? There are actually two ways. The simplest is to use the context lib.contextManager decorator on a generator function. As we see here, when we create a context manager this way, we can write it as a continuous piece of code. We can think of the yield statement as a proxy for the whole code block that the with statement contains. If that block raises an exception, it will look to our context manager code as if the yield statement raised that exception, and we can wrap it in a try statement to deal with the exceptions that might occur. A moment ago, on screen, there was an example of using an open file as a context manager, and that statement had an as block. A moment ago, we saw an example of using the file open command as a context manager, or rather the open file that was returned from it. And in that example, we saw the as clause to the with statement. The as clause lets us bind a value returned from the context manager to a variable accessible within the with block. The as clause lets us bind a value returned from the context manager to a variable accessible within the with block. If we yield a value from our context manager code, that value will be assigned through as to the variable accessible in the with block. In this example, we yield a function that prints the word during. So the entire result of our context manager is to print the words before, during, and after, assuming that that function is called. And typos aside, we see that it does. We can also write context managers by adding the double underbarred enter and exit methods to objects. Any object that properly implements these methods can be used as a context manager, which is how objects such as open files and database connections are able to do double duty as context managers as well. Here's an example in which we create a specialized version of a dictionary which can serve as a context manager. Within the scope of the with block, we can read and write data through the object that we returned from enter, but those changes will only be applied to the main dictionary if the block exits without raising an exception. The return value of the enter method is used by the with statement for the value to assign through the as clause, just as the yielded result was in the previous example. The exit method needs to accept parameters that specify the exception type, exception value, and trace back if an exception was raised in the with block. If no exception was raised, those parameters will all contain none. If an exception was raised, we need to decide whether and how the context manager will handle them. In our example here, we decide whether to apply the changes to the main dictionary based on whether or not an exception was raised, but otherwise we ignore the exception. If we wanted Python to consider the exception to be handled, we could have returned true from the exit method. That would be functionally equivalent to catching the function with a try except statement in a context manager.con. That would be functionally equivalent to catching the exception with a try except statement in a context lib.contextManager style context manager. And here's our transaction dictionary in action. As you can see, the first transaction was successful, and the result was committed to the main dictionary. However, the second transaction involved raising an exception, and the result was not committed. Now that we have a good grasp on the mechanics of context managers, we only have one more piece of programmable syntax to cover. So the with statement runs code before the block begins. So the with statement contains a code block, and runs code both before that block begins and after it ends, even if an exception was the reason why the block ended. Using the context lib.contextManager decorator, we can create a context manager using a single generator function in simple syntax. We can also make an object into a context manager by giving it double underbarred enter and exit methods. In the next video, we'll change the way variable accesses work by using descriptors.